To go. Hello, everyone.
Hello. Hola.
At least you can let everyone in. We are ready to start.
Okay.
In 30 seconds.
Nice music.
Make sure you all look your best, because this meeting is, of course, live stream in YouTube. And after the meeting, the link stays there forever, for as long as YouTube exists. Maybe later it gets renamed into X or something, God knows.
Oh, I can't share my screen.
Oh,
Oh, maybe because it's through their thing.
MicroLEDs are seen as the next logical step for OLED screens in phones, high-end vehicle displays, and extended reality headsets. They offer high contrast and brightness, long lifetime, low power consumption, and are ideal for transparent displays. But the challenge is that such a micro-LED display may contain up to 25 million discrete components of less than 50 microns in size, which need to be accurately positioned. So how do we make these photonic miracles when traditional pick-and-place machines would take weeks to assemble a single display? For answers, join us on Tuesday 21st November for the next Optica online industry meeting, which goes live at 10 a.m. in New York, that's 4 p.m. in Munich. And here's the lineup of speakers who will kick off the discussion. Michael Hamm from Audi, Henry Sackman from Jabil Optics. By the way, we all know that Jabil is in the news after acquiring Intel's transceiver line. Niels Heurer from Pixeligen Technologies. Edward Da Silva from Forvia, one of the key Tier 1 suppliers of micro-LEDs. Alexander Lusing from Alos Semiconductors. This Optica corporate member provides gallium nitride on silicon epi wafers. Michael Boroson from the worldwide renowned OLED Works. And all the way from Poland, we have a key company in the manufacturing of customized polymer. Piotr Saska will be representing Noctiluca. And Elox Displays will also be in the room, represented by Paul Schule. Nikhil Hain from X Display, the company that does the microtransfer printing of micro-LEDs at volume production. And that's not all. We have two experts in quantum dots. Artur Podhorodecki from Q&A Technology in Wrocław, Poland, and Igor Nakoneczny, the founder and director of Quantum Dot from Belgium. That's the lineup, so let's get started!
Ladies and gentlemen, are we all ready? Are we all ready? I see a lot of friendly smiles here. The point of this meeting, for the next 2 hours, the point of this meeting is that we all understand what is the answer to your Optica question. What can you do for others, and what can others do for you? My name is Jose Poto. I am Chief Technology Officer of Optica. I'm your friend. And together with our other friend, Olga Ratz, and the whole entire Optica team directed by Elise Fries-Gates today, we are trying our best to make sure you find ways to work together, you find ways to collaborate. On the next 2 hours, we're going to try our best to make sure that we provide you a platform for cooperation. Optica is many things: a publishing group, an event organizer. Optica is also a global industry network. The corporate engagement department of Optica provides you the tools from market intelligence to connection to potential partners, suppliers, customers, talent, and investors, as well as long list of market reports. We have now very close to 600 corporate members in our list, and around 90% of them have less than 100 employees. That just represents the photonic industry, which we love. We love very much. I speak today on behalf of the Corporate Engagement Council and our 2023 Director, Professor Michal Lipson. I also would like to remind everyone that this meeting is to connect potential suppliers and integrators. And today we have a really beautiful list of integrators: Audi, Forvia, OLED Works, Noctiluca, and Elox Displays, and enablers. Enablers are the companies who came here providing solutions: X Display, Jabil, Intelligent, Alos, Q&A, and Casting Dot. But let me remind you one thing. We took everyone in this meeting very seriously. You know how seriously? We studied each of you And we made this supply chain slide, which we will share with the rest of the world. After this meeting, this slide will be in LinkedIn, in Twitter. We want everyone to know that you're here and that your company is positioned by Optica in what we think is the right place in the supply chain of OLED and micro-LED displays. If you don't agree with the position of your company in the supply chain, please complain to Dr. Olga Ras, who made a lot of effort making sure that she understands what the role of your company is. And together with Olga Ras, I would like to remind all of you that this meeting is almost by the end of our season. OLED and micro-LED displays, the last but one meeting of this season. The next one is just after the Christmas holiday. We do quantum computing. Mark your calendar, 16 January, quantum computing. I also would like to remind everyone that if you want to get access to all our market reports, we have like hundreds. All our market reports are at optica.org/market reports. Go to optica.org/market reports, select what you want, click, 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 click. Go to the bottom, put your email address, they come to your mailbox. No need to remember username and password. Honestly, I don't remember any of my username and passwords anymore. And to let you know at the end, this meeting is live streaming YouTube. So make sure you look your best because you're going to be famous YouTubers of the world. If you want to get in touch with any of the participants today, all you have to do is send me an email, jpost@optica.org. And please make sure that all of you understand that after the meeting, the link will be still alive in YouTube. Share it, watch it, follow it. If you want to get in touch with any of the other participants, just contact us and we'll make the introduction. Olga and me love making introductions. It is time to start, and today I put on a tie because I want to be elegant. Why? Because the first speaker today is also very elegant. I would like to welcome to an Optica online industry meeting one of the best car makers worldwide. I love the Audi A7. Olga, what did you do to bring Audi to speak? Olga, I'm gonna allow you, I'm gonna be encouraged by allowing you to introduce our first speaker from Audi today.
Well, then it's my great pleasure to introduce really, and our first speaker is Michael Ham, who is not only Audi, but also the driving vision use. And this, I would like to let everyone know that this meeting is actually organized in support with the DVN, which is a very important partner for us in terms of we start to look at the fields of, displays. And they helped us a lot with organizing this meeting. And that's why I want to offer Michael to start actually and do his intro to this meeting. Michael, the floor is yours. Please share your screen and say a warm welcome to everyone here.
Okay, I say a very warm welcome to you all. Thank you, Olga, for the introduction. I try to share my screen. Here's the screen. What you see here is no Audi slide because I am here supporting driving vision news, as Olga already said. I'm Michael Hamm, that's right. I worked now in the headlamp department as head of the headlamp department in Audi for the last 10 years. Now I have some additional jobs. I'm a lecturer at the Technical University Darmstadt. Some of you have heard from the ESAL conference that just has happened in September. I'm also working for Driving Vision News as a kind of advanced journalist and advisor. In this factor, my screen is not working. Yes, now it's working. In this area, you see Driving Vision News. Perhaps some of you have heard about. It's slightly different to the world of Optica, but it has a lot of interfaces and overlappings, and that's the good reason to perhaps make some joint efforts. DVN, this Driving Vision News, is existing, as you see, for 15 years. We have about 250 customers, let's say friends worldwide that share this DVN community. We have about 25 experts that are, let's say, in the DVN, let's say, well, how can we say it, not the steering board. And we all do together making news, about 7,500 articles that are published in the DVN newsletter. We have done up to now 180, no, it's not true, it's 185 monthly reports. And what is the specialty, which also shares, we have established in the last years about 28 workshops where the industry is meeting the whole supply chain. So the tier 1, tier 2, tier 3, and the global car makers are sitting together in these presentations. For these monthly reports that are available for the community members, or 185 reports. The last one published I was the one who was writing it. I made a 60 pages report about the company Osram. And they are also active in micro-LED and in quantum dots and all that stuff. So it will be interesting to see all of that. So I think that's all that you have to know about DVN and driving vision news and why I am here. And you see on the bottom left, let's say the community members. It's like Optica showed, there are many community members, but in this case, these are the community members which are more the global car makers in the tier 1 and tier 2. So that's all. Thank you for your attention.
Thank you, Michael, and thank you for your support for organizing this meeting. Jose?
I love to have Audi in the room. I'm sorry. I love DVN. And by the way, Peter Fretti, I know you're watching this. He's a great friend of mine. And Michael Harman, all the way from TU Darmstadt, my good friend Wolfgang Elsasser is also watching us. But Michael, you are coming from Audi as well. And I would like to take the chance to understand a little bit better, in your opinion, what is next for micro-LEDs in automotive? What is the biggest challenge that all the people here with us in the room could help you solve?
The basic world of the future is no longer as we have done in the automotive business, in the lighting business for a long time. We were hunting for new technology. We were hunting for new, better efficiency, for better, let's say, light on the road. I think now we have achieved a very stable thing. All of you which are driving one of the most modern cars with the most modern headlamps perhaps can agree that it's much better than that what we have perhaps 20 or 50 years ago. When we are driving in the United States with the sealed beams and in Germany with the old tungsten filament bulbs, that time is past. The world of the future is called digitalization. And this comprises all what we are discussing today, micro-LED, OLED, all that things that can contribute to digitalization.
We have today in the room manufacturers of OLEDs, manufacturing micro-LEDs, and they're going to talk a lot. But I also know that Audi develops one of the best headlamps together with your partners. They are beautiful. The MLA technology in the next Audi is fantastic. I can tell you, Michael, we have in the room people from SUS Micro-Optics. We have in the room people from Heidelberg Instruments. They provide great micro-optics, optical technology. One question, very easy. Glass or plastic?
Plastic.
Plastic?
At the outside of the lamps is plastic. What is inside, that is glass.
Wilfred Null, coming all the way from beautiful Neuchâtel in Switzerland. Wilfred, did you hear what Michael just said? The outside is plastic, the inside the glass. I don't know if he was trying to make everyone happy or if this is really the future for MLA technology entering the automotive. I know that you are automotive qualified manufacturer, micro-optics in volume production, and congratulations with everything that is happening lately. What is your take on this?
So I think it depends on what category you talk about, what level of automotive class you're talking about. So for the so we are now in two high-end cars with polymer on glass. The lens areas can be very small. You get a very nice and uniform illumination. We work with the tier 1, so it's not really our invention. We are very good at the technology, but the design is sometimes coming from the tier 1. So the tier 1s are pushing it. They love it because it's very small. The designer love it because it's very small. And we can do things with polymer on glass that are still difficult, very difficult to do with precision injection molding or CLA-based design. So I think it's still not 100% settled, which technology is the best, which one is the most suitable one. What we push, and that is what we work on, is on a technology that is based on a semiconductor technology. So that means we can easily scale up. We can standardize the core of the illumination system, and then the automotive designer can build around the core whatever they want. So basically, it's a transistor. So the transistor of lighting, and then you can build around an area of transistors. You can build something around it, whatever you want. It's up to you. So, but we want to push this module, this lighting module, which is very small, a square centimeter, maybe 2 square centimeters, and then the car designers can build around what they want. We want to standardize this. We want to push this technology.
I saw many
that's
people
the
in the
idea.
room, they nodded along when you said the transistor of lighting. I'm going to quote you on that, Wilfred. Michael, he seems to agree that the glass is really the core part of the MLA technology. Audi makes great headlights. The Genesis P90 is also great headlights as well with the glass-based MLAs. But Heidelberg Instruments, I want to come to you now to open up the meeting, to kick off the meeting. Dominique, glass or plastic for the next generation headlights?
Hello to everyone. Yes, actually, we are a machine manufacturer, so we don't do like real micro optical elements, but we do exposure systems that can create mold for micro optic elements. And usually we work on photoresist. So with grayscale technology, we can structure the surface of the photoresist to create 2.5D topographies. And we also have now 2-photon polymerization machines that can expose 3D structures directly in some material. So it's neither plastic but we do mostly like mold for the fabrication of micro optics, or our machines can do the mold. Yeah.
We have a chat here, so every one of you, please share your vision on this first question of the meeting. Glass or plastic? Michael, thank you very much for being with us. It is great to have partnership with DBN. My colleague, Dr. Olga Ras, will be one of the keynote speakers, will take a keynote role at the DBN meeting. We are looking forward to interacting closer with the LiDAR community. But let's start. Today is a really big day for me because I have great friends in the room. Igor from Costume, that is so great to see you again. Let's start the meeting. And today, I would like to start the meeting with one of the key companies as a tier 1 supplier in the sector. It is great to, for the first time at an Optica event, we welcome a very important company in our ecosystem. We welcome Forvia. Forvia has been helping many of the tier 1s and automotive suppliers in bringing advanced technology, advanced lighting, advanced optics. It is great to have them in the room. Ladies and gentlemen, we welcome today Eduardo Silva from Forvia. The room, the floor, and the attention of everyone is yours.
Thank you, everyone. So thank you for giving me the opportunity. Let me try to share my screen. I think you should be able to see the screens now. Yeah.
Gorilla Glass clear.
Okay, great. So I think I prepared a couple of slides today to share a bit the vision of the display, evolution into the automotive cockpit as we see it. Moving forward, I think it's very well aligned with what has been said before. I think we are moving towards more digitalization, digital cockpit, right? From today's situation, which was actually until before very much function driven. Now we are really more in the immersive and perceptual kind of a user experience. And this is, of course, driving a lot of opportunities for the whole ecosystem of players and suppliers. I think it's beyond to be a trend. We've seen a lot of different concept cars and also different cars that are actually popping up everywhere in the world. I think in China market, there is many digital cockpit examples. But of course, this is fostering a lot of new questions in terms of performance and integrations, because now it's not anymore one display, one function, but it's more and more multi-functions, cross-domain interactions, and immersivity become more and more key. So of course, this is driving and explaining a little bit the situation in terms of market evolution, right? So that's a growing market, display market, I think overall for automotive. So it's more larger, better, brighter, sharper, right? The screens performances are very improved in say the near future, and we'll keep going with this improvement. And we see the emergence of these new technologies, which are OLED and MicroLED, as being expected to take some share of the global markets for display in automotive, mainly driven by their benefits in terms of performances. But in that page, it's important to remember that the performance is increasing, okay, overall. But that's of course fostering lots of opportunity, but also lots of challenges, right? I think the challenges are around the architecture, of course, energy, distraction, and perception. So because more digital content is also raising up the issues in terms of how do you perceive the digital content? How do you make sure it is understood and well, caught by the user and drivers? And of course, this is increasing with the size. So that's something that can be seen as a kind of an exponential thing. So for this digital cockpit, there is a new paradigm in terms of integrations coming up. In order to fulfill, this larger integration, this larger size. So it's limiting the possibilities on how you can fit that into an automotive cockpit. There is also more constraints in terms of how the ambient light will impact the readability of the content, right? With some more safety contents to be displayed in the digital screens. E-mirrors and other types of applications that more and more are going to be, helped with screens, and also some more, let's say, real-time augmented reality interactions to improve the driving experience. So that's all together create, some kind of, new types of integrations and constraints, right? So what we can see also as an opportunity is, of course, if we put the screens over in IP, because it's very large, then maybe there is opportunity to play with the resolution, okay? And it's very good to have this discretionary approach of the micro-LED, for instance, in order to adapt the density of pixels to the position relative to the user or to the driver, for instance, to drive the cost into reasonable areas. And so what we've done at ARVR is basically to create this concept of immersive display, which is bundling different display technologies, different LED types, different pitches, right, in order to create one screen, right, that can serve different applications and that can actually be integrated over IP, nearby windshield, everywhere, with this seamless transition between high definition and low definitions, right, but still perceived as it's one screen, right? And here we've been actually creating, this is some real product we have, where we've been actually able to make this pillar-to-pillar display that is actually fitting various types of LED displays and let's say high definition TFT and also mini LED screens into one piece, right, as one screen, operated with one video stream and with a good color matching so that it gives really an immersivity, right, of the experience that drive actually the different use cases that needs to be supported by the screens. And last but not least, I think this is something that we are continuously working in towards actually improving the concept. And this is where we are investing a lot of time with our partners, ecosystem, wise to introduce this new concept with micro LED, right? And creating this type of bundling of different pitches of LEDs down to really small micro LED in order to support this approach of, redefining what should be a display system, right? So that's it for today's presentation.
Thank you very much for being here. Thank you for bringing Forvia to the meeting. Just don't be surprised. It's a meeting about cooperation and collaboration. We want to understand what are your challenges because we want to help you with them. Edward, this is your Optica question. We have today 70 people in the room, some people watching in YouTube, and thousands who watch this meeting afterwards. The last meeting was viewed by, I think, 4,000 people. So what can you do for them? What can they do for you?
I think what we can do for them is to give them an opportunity to serve automotive market, is defining, redefining what is a display, right, in the automotive industry for, let's say, bringing alive solutions, right, that in the end will create value for the drivers and the users, okay? So that's what we can do together. I think what we are looking for is, the possibility to address those challenges I just written in that slides, right? How can we, define, the high definitions if it's micro LED, for instance, in order to be able to driving it very easily, right? And to integrate that very easily into such a kind of a system, right? So that's where I think for me, the interactions or interface, connections, right? And creation of this type of, let's say, standard modules, right, would be of interest for me.
I would like to tell you that in this room, there are many people who want to work with you, and efficiency is something that we love. So allow me to bring to the floor one of our guests today. It's for a company that has made efficiency one of their biggest selling points. We have in the room, I don't know if you have met them already. Do you know already the company, Edward, do you know a company Pixel Legend?
Yeah.
but you're gonna meet them because I have in the room Jeffrey Anderson from Pixeligent. Pixeligent is a company that have actually focused on increasing the efficiency of lighting based on micro LEDs. Jeffrey, thank you very much for being with us today. And oh, sorry, I have Neil. Neil is with us today. Neil, could you tell us what you do and tell us how you could help Forvia increase the efficiency?
Yeah, good morning. Would you like me to share my slides at this point, or?
Of course.
Okay.
That was my cue for you to show that.
Sorry.
No, please don't apologize. Great to have you here. Pixeligent is a corporate member of Optica. Please, all of you companies, if you want to continue, for us to continue doing what we're doing, please become corporate member of Optica. The only way you have to support us, there's no other way. You can buy us a drink. We don't consider that support. Please fill out the form and join. Neil, whenever you are ready, bottom of the window, just a green arrow up, and afterwards you got to click on the window you want to select with the universe. So bottom of the Zoom room, there you go.
Sorry,
we are seeing,
everybody.
We are not yet seeing the slides. I think we are sharing with us the wrong room, the wrong window.
There we go.
You go now to presentation mode. I think we are ready to. Yes, fantastic. The first yours.
Sorry for the long suspense builder there. So yes, thank you for having me here today to tell you a little bit about our company, Pixeligent, about our nanomaterials that can help to improve efficiencies of displays. And, you know, I'm Neil Pashir, Vice President of Product Development. And let me just jump in. So what do we do at Pixeligent? We, you know, synthesize nanomaterials, more specifically nanocrystals, zirconia and titania nanocrystals. Why do we do this? We do this mainly for the high refractive index properties that help enable next generation displays, augmented reality headsets, as well as 3D sensors. So our zirconia and titania nanocrystals are really special, and our kind of expertise is bottom-up synthesis of these materials that allows us to control their size and particle distribution. We have sizes from zirconia of 5 nanometers up to 20 nanometers for our largest titania. And this, you know, careful control of the particle size and distribution allows us to have materials without haze and just excellent optical properties. And, you know, these PixClear compounds, we now have moved into formulations a few years back because we think it's a business model that helps us to, you know, better help our customers more quickly to come up with their solutions. 2 examples of those are our PixJet and PixNil formulations, which I'll tell you a little bit more about. And these are all, you know, ready on commercial scale, multi-ton, and we, you know, we make our formulations to be drop-in solutions that our customers can easily work with. So switching to the film properties, you know, these are high refractive index materials from 165 up to 2.0. And the reason we want this higher index for this application is to, as closely as possible, match the display stack, be it OLED or micro LED. Again, you know, value proposition is the high transparency and low haze. And, you know, the PixJet is made to work with inkjet printers, typically solvent-free formulations. And our PixNil, NIL stands for nano imprint lithography. These are typically formulations that are giving thicknesses closer to 100 nanometers up to a few microns. And these are also made to work with spin coating, you know, which is more applicable to micro LED or slot die, which is very common coating technology, you know, for OLED and other, you know, display concepts. So what is the main benefit that we're offering? It's increased light extraction, so improving the external quantum efficiency of these devices, driven by high index. And to explain this, I just included a small diagram on the right-hand side that I think many of you are familiar with. Even though, you know, LED, micro LED and OLED are, you know, intrinsically very, very efficient systems. You know, for example, OLED with phosphorescent stack can have internal efficiencies, internal quantum efficiencies of 100. A lot of that light gets trapped inside of the device as the light comes out into glass or into a touch panel or whatever the next layer is. So by working at this, you know, and this is, you know, defined by Snell's law, it's angle dependent, but by basically working at that interface above the display, for example, using a micro or a nano lens structure, as you see in the second picture here right-hand side, we can help this light to escape out of the device and improve the overall, external quantum efficiencies or your current efficiencies. And this works for all colors. And it's shown here that maybe air is the next layer, but that's not the case. And it's really independent of whether that's a touch panel or what that next layer is. And the reason I shared these pictures on the bottom here on the right-hand side, these are just to show our capability that we can produce very, very fine structures. These are produced by nano imprint lithography, 100 nanometer, roughly 100 nanometer height on these. And if you look at the TEM image on the right-hand side, you can see that our nanoparticles are very finely dispersed throughout this structure. That means that, we can have very, fine structures, and at the same time, the refractive index is going to be the same everywhere in these structures, which is important for any type of device that you're building. So, yeah, finally, I think just to point out that nano imprint lithography and inkjetting, processes are, of course, much cheaper than photolithography. And, in terms of light stability, using nanocrystal materials, we have zirconia, which is, completely stable, with UV light. And we've developed a new type of nanoparticle based on our, capabilities there. It's called core shell, where we coat zirconia on the outside of titania, which gives you higher index with excellent stability. So sorry if I went over on the time. Happy to answer any questions.
No, don't worry about that, because this is your home. You're a corporate member. We will make any exception possible with you. But most important for us is to understand your answer to the Optica question. What can you do for the others? What can others do for you?
So yeah, we can help to. No, go ahead. Please
go ahead.
So yeah, we can help to improve the efficiency of the light outcoupling efficiency of these devices, and it's really independent of the type of stack that you're doing. By offering materials that work with different processes, I think we can address any of these concepts. So
you're using lots of technologies from nanoimprint lithography, for example. So I think Wilfred Null from SUS was already taking notes for that. And I believe there is a lot of room for cooperation. Stay tuned, because we're going to come talk to you, especially after OLED works later today. But now I want to welcome to the room another corporate member of Optica. Going all the way to beautiful United Kingdom, I'm going to welcome a very extremely dear friend of mine, il capo, il professore, il maestro, Antonio Raspa, all the way from Luxinar. Tell us, what's on your mind? I know you have a question for Forbian.
Yes, thank you so much, Jose. No, it's a quite a general question, because I was really impressed about this large cockpit. So why restrict ourselves just to the cockpit and not use all the windows and the windshield? And going more in the technical side, how are competing MicroLED for cockpit against head-up display on the windshield? This is really an open question to all the people in the room.
Yeah, I think there is no limit. For me, if I may answer, Jose, right? I think there is no limit indeed. So it's limit would be imagination of the customers. Of course, it needs to bring values. And when you rise up the head-up display, it's a very good example. I think the micro-LED, for instance, is very bright. So usually, the head-up display is a limited window, right? And it's coming with, some kind of constraints in terms of how do you fit that into your car, right? Well, I think if we can have like a kind of direct view displays using the brightness of micro-LED, and it could be now becoming pillar to pillar or even more, right? As you said. So I think it's a very good point from your side. I think in terms of maturity, of course, it's known, right? Micro-LED is maturing right now, but there is a transition, I think, that is emerging more and more. I think we see more and more mini-LED, right? Which is actually rising up with the possibility to have density around 40, maybe 50 ppi on the PCBA type of backplane, right? Which are very interesting, in my opinion, because this is something that might be very, very good and very easily integrated and bundled with different size of LEDs, which might be much bigger, right? So you can create this type of variable pitches, as I just mentioned. and it's opening a lot the possibility of creating a cockpit immersive, right? Approach. You probably have seen the sphere in Vegas, right? Which is a kind of an extreme one. But I think to be more reasonable, I think there is no limit. It's more opportunities, right? To by using different type of LEDs to mitigate the cost, which is of course one topic, and take the opportunity of this technology to have a wider experience, right? And to make it more inclusive for the occupants as well, right? So I think these are very good objectives that we try to fulfill as much as we can with such
Edward, I 100% agree with you here. The big elephant in every automotive room is the price. And I think there is where we always have to consider that Michael is nodding no when I said that. And I really like to see Michael Ham from Audi and DBN. What's your take on this?
Well, I think it is a great idea to enhance the display from that what we have today, which is only a very small one that we had not long ago, the analog devices. If we now see the example that that Eduardo was showing, to make it bigger, I think there are few limits, but there are limits which mean stray light and safety concerns. And it's not only the price. You can do the most cheap, super thing if you have, let's say, some safety concerns when you make an accident, you crash, anything like this, or you have glare that is going through this front light. This is the limit. So I think that if we look to the safety sensitive parts, which are just in front of the driver's view, and the less safety relevant part, where you normally look to your hood, which means 10 degrees down from the driver's view, you are normally not looking to the road, but you're looking to your hood. There, where today we have the head-up display presentations, you could put something like this, but not over the old screen, because then there will be the finger that's saying, hey guys, we have to have glare limitations and we have to respect all that safety issues. But below or on the side windows, there is a large field.
Absolutely.
I would like to welcome to this discussion. There's a company here that everybody's working with, but very few know them. But one of the biggest companies in our industry, definitely the biggest as a corporate member, is Jabil Optics. Hendrik, we are seeing this discussion about efficiency, about increasing the size of display, about Edward saying that cost is also one important parameter. Where do you stand? And tell us how you can help these companies in the room being even more successful.
Yeah, hi. Yeah, thanks for asking. Well, what we at Jabil Optics can provide is design and engineering support in integrating the displays into the final device, and then also manufacturing the final device in terms of prototyping. And we also can go to Jabil's mass production solutions here. So let's just have a look on this. Come on. So what we can do in Jena, in the heart of Germany, is integration of all of those micro displays, maybe OLED or MicroLED, which we are already doing for ARVR devices as well as for automotive. So we have all those tools in place in Jena on wafer scale. We can do 2D, 3D bare die assembly. We can do dynamic tuning in terms of active alignment of the devices, and also are able to deal with our company in Hasselt in Belgium on PCBA level. And what we offer in Jena, come on, go. What we offer in Jena is a large clean room where you also, as a customer, can have access to 10 millions of equipment, and then for sure also the transfer to manufacturing in Jabil's mass production sites worldwide. So if this is of interest for you, then please don't hesitate to get in touch with me.
Thank you very much, Hendrik. It is very interesting for us because the next speaker is a company that actually has enabled many of us being successful in the room. We are going to one of the most exciting companies in the field of OLED lighting. Actually, I want to say that a meeting on OLED lighting doesn't make sense without having OLED works in the room. Hello, thank you very much, Michael, for being with us. The floor and the attention of everyone goes to you. Help us help you. The floor is yours.
Well, Thank you. Let me share my screen.
We are seeing lots of controls, but you go to, yes, presentation mode. Fantastic, all it works.
Okay, well, thank you very much for the invitation to talk today. What I plan to talk about today is our multi-stack OLED technology for high brightness and long lifetime applications. So just to be clear, we are an organic LED company. We do not do micro LEDs or mini LEDs, but our focus is on very high brightness. Most of us are used to OLEDs in like cell phones or TVs where the brightness is pretty limited. But what OLEDWorks focuses on and specializes in is ultra high brightness, long lifetime applications, so that we can get into these kinds of applications where micro LEDs are being targeted, but we can do that today with technology that already exists and has been proven. To explain the multi-stack OLED technology, the basic concept here is a typical OLED, like in your cell phone, is composed of what we call one OLED unit. That's a emitting layer surrounded by transport layers placed between the anode and the cathode. With multi-stack OLED technology, we take that OLED unit and we put 2 or 3 or 4 or even 6 OLED units on top of each other with the charge generation placed in between them. And what this does is it allows you to get extremely high brightness without losing lifetime that you would lose in a single stack device. So an example of this is in the automotive area in the taillight. The taillight is a red OLED that needs to be at 2,000 candela per meter squared brightness. To achieve that, we use 2 red stacks, a 2-stack device, which gives us the efficiency we need to get 2,000 candela per meter squared while still meeting the lifetime requirement for an automotive application, which is on the order of 15 years of actual in the car and tens of thousands of hours of operational usage. So that's one example. To get to even higher brightnesses, such as the brightnesses needed for daytime communication or stop or directional turn signal, we need to get to something like 10,000 to 20,000 candela per meter squared. Now, just in comparison, the screen on your phone is definitely lower than like 500 candela per meter squared, and your TV also. So these are extremely high brightnesses, and again, we achieve that by using this multi-stack technology. By combining the multi-stack technology with our outstanding encapsulation technology, we can make panels and have proven that we have panels that are available to last the lifetime of the car. These current products are right now made on rigid glass. So there's an answer to one of your questions as to glass versus plastic. OLEDs are very sensitive to moisture. So glass is a great moisture barrier, plastic not so much. And barrier-coated plastics so far are very expensive. And so for automotive applications, glass is the right choice. Our current product's on rigid glass, but we're also in development on bendable glass products. And actually, there's a project right now we're working on with a specific car release planned, so it's coming soon. And these bendable OLED panels will be able to follow the curvature of the car exterior in a way that you can't do today with the rigid panels. We see market applications for this technology, for the lighting part of this technology in rear combination lights, chimsels, badging, digital badging, digital logos, interior lighting, and even exterior white lighting to augment the daytime running lights. Not headlights, as OLEDs are a Lambertian light source, but anywhere that you want wide viewing angle of the light, OLED is the perfect technology for that, and the multi-stack technology really enables that. In addition to lighting, OLEDWorks also works on micro displays, and again, our focus is on high performance microdisplays, extremely high brightness, high power efficiency, and long lifetime. And we do this again with a multi-stack approach. In this case, we do a multi-stack white OLED with color filters. What this does is gives you design freedom because each stack is actually a different color. So you have a blue stack and a red stack and a green stack, and by combining the stacks to get the white that you want, you can get increased color gamut. You can get what we call balanced subpixel currents, so that each pixel fades at the same rate, so you don't get color shift over time. The color of the display remains neutral over its whole lifetime. And again, the applications that we're looking at here are, very high-end AR and VR applications where extremely high brightness, tens of thousands of $10 per meter squared are required in order to use low-cost optics or to have very low lag time for head movement, so that the user doesn't, get that delayed response from turning their head. So again, this is all premised on this multi-stack technology, which we have been practicing for the last 10 years. So this is not for the faint of heart. A multi-stack, OLED of 6 stacks might include 30 to 50 layers deposited, where each layer has to be controlled to within a nanometer or even a sub-nanometer of its target thickness and composition. Again, we've been doing this for 10 years, so we understand how to do that in manufacturing in high volume. And we are, currently working with companies who want to apply this ultra high brightness, long lifetime technology. Again, as the topic of today's talk really and today's meeting it's about strategic partnerships. We are, still a relatively small company compared to, some of our partners, whether that's on the customer side or the supplier side. But we very much work closely with both suppliers and customers to apply this technology to the appropriate places. So that might be, working with the OEM, working with the tier one, and also working with our suppliers in order to bring together all the different components needed for this technology to be successful in the application we're targeting. And we see more applications possible and more partnerships certainly possible on the customer side, as well as on the supplier side. For example, a Pixeligent or companies like that can help us get higher efficiency. It only increases the number of opportunities for this technology. So we're very excited about this. We think that this is really the approach that's going to be correct for the short term. And even direct view displays, as we talked about the car interior, having an ultra high brightness, long lifetime direct view OLED display, with very high range of brightness, so that at night it can be very dim and at daytime it can be bright enough to see with great contrast. We see applications there that we also are interested in pursuing with the right partners. And that's all I had.
Thank you so much, Michael. I think with it's excellent presentation, and I don't even need to ask extra the Optica question, what you can do the others and what the others can do for you. You have already answered it. And with so many pioneers at the wheel, you never fail to develop the cutting edge products. I guess during your presentation, the Hendrik and Eduard were taking notes. Also, Niall. Hendrik, what is your comment? So, have you already had a chance to? I guess as the largest contract manufacturer, you have an opportunity to touch or to play with the latest advances in technology. So, have you had already a touch into all the flexible OLEDs and everything what they can do for the lighting?
Yeah, thanks for asking, Olga. Funny enough, I was just typing a message in parallel to Michael to get in touch on this, because I think this is really interesting. And we are looking out to high brightness micro displays, mainly for micro LED based, but also OLED based. So this is exactly what we are looking for.
Yes, Michael, and that's, it's also very interesting, how to say, touch, because, when you start to read or research online, what the Google or whatever ChatGPT tells you, that of course the micro LEDs will surpass by the brightness the OLEDs. I guess the ChatGPT is not yet updated to the latest status that you're suggesting. So maybe you need to take care. And Eduard, what would be your comment? Do you see a lot of potential behind this work? Have you already also written a personal message to Michael?
No, not yet. No, I think it was interesting indeed. So I think, I think there is many applications for exterior lighting as well, using OLED already. So this brightness topic is maybe known from display high definitions, right? Systems which are having some time of brightness, let's say lower brightness, right? But indeed, the OLED can be really bright, and it's already serving a lot of applications, And when we look at the external lights, for instance, there are many applications which are very beautiful and very nice. I think using the very slim designs and flexible substrates, I think it's very, very good applications for these technologies. And very, very exciting to see your presentation, Michael. Thank you for sharing.
I think you should really get in touch after the one. Yes.
Flexible substrates. Edward, you spoke about flexible substrates. Is there any new advances that you have seen in the field of flexible substrates for OLED technology?
I think it's hard to say. We need to know the reference, but I think it's continuously improving. I think in reliability, right? So I think there is now we see the fancy stuff is rollable, OLED as well. It's really, it could be really very, very, very tight bended, very tightly, right? I think it could be. So I think it's improving in that way, maybe. But there are still some questions. But I think it's continuously improving. I really believe it's the case. Maybe someone can comment better than me for concrete examples or improvements. I think maybe this is where you want to go. But I think I wish someone can comment further.
I think we have someone in the room who can indeed comment further. So I would like to actually give a voice to one of our guests today, Paul Hartmann from Genium Research, because they are specialists in the roll-to-roll, and I guess know everything and even more about flexible substrates and how we can work with them. Paul?
Yes, hello, Olga.
Share with us some of your expertise.
Great, thanks for giving me the chance to talk to you here. Yes, as you said already, there is some additional technology which is suitable for both MicroLEDs and OLEDs, probably to enhance the properties. It is basically very small, very flexible optics. Let it also be freeform optics that you can print on flexible foils that you can transfer as well to the surface of OLEDs or MicroLEDs to enhance the optical properties of those devices. And we have pioneered this area at UNM Research in Austria for quite some years, and we are now partnering with a lot of partner companies in a European Union pilot line project, which is called Fabulous. And in this project also, I see here some colleagues from SÜSS Micro-Optics, which are providing here specific solutions for the wafer scale pillar of this very interesting pilot line. And together with all these technology partners, we like to serve the worldwide industry, of course, with new solutions in freeform micro-optics.
Thank you for your comment, Paul. I wanted to ask Niall, actually, because you're our expert for all the materials for the OLEDs. So what is your process, or are your materials also compatible with roll-to-roll, and with which other production techniques, Niall?
Yeah, in principle, they are applicable by roll-to-roll. There's nothing limiting that. And, as I mentioned before, slot die, inkjet. You know, there's the other ones I haven't mentioned, spray coating. That's really not I think a typical process used in display, but certainly roll-to-roll is something important for flexible OLEDs and technologies going forward. And yes, we could be in that process.
Thank you. I hope there will be quite a few collaborations on the flexible OLEDs for future. But every OLEDs is actually starting with the chemistry behind it. And we have here professionals for chemistry for the OLEDs. And I would really like to invite our next speaker is Piotr Czarska from Noctiluca, the very well-known provider for the OLEDs chemistry. Piotr, I hope you will go back online now and actually introduce yourself. Here we go.
Thank you very much for such fantastic introduction. I will try to share my screen. I hope it will work.
It should. We practiced.
Yes. Can you see my presentation?
Yes.
Okay, so hello everyone. My name is Piotr Czarska, and I'm really happy to be here and represent Noctiluca on Optica event. In Noctiluca, I'm responsible for coordination of R&D processes. Generally, I'm organic chemist, and currently I'm completing my PhD on application of TADF emitters for OLED applications. Okay. As Noctiluca, we're a deep tech company based in the heart of EU. Our goal is to develop highly efficient emitters of third and fourth generations for OLED applications, but also high performance materials, for example, hosts, transporting materials, injection materials, blocking materials. I mean, the other materials used, not only emitters. We deliver our proprietary materials for PVD and inkjet printing uses, as well as node compounds in custom synthesis model. Among our partners are LG, Inuru, TCL, Tianma, or Filgen. We cooperate with institutes and universities. We have R&D team in Korea dedicated to building devices. We cooperate with R&D teams in different parts of the world. We're members of Optica, DFF, European Photonics Industry Consortium. For almost 2 years, we are listed on Connect. We operate in 4 areas: in-house research, chemical CRO services, custom synthesis of known materials, and sublimation services also. Our team has 15 years of experience in most challenging chemical projects. We're experts in organic synthesis. We have also fantastic analysts. Our laboratory is fully equipped with special instruments for synthesis, for purification, scaling the processes, for quality control, for characterizations of the obtained products. In case of chemical CRO, we can offer assistance in all basic chemical reactions, design and optimizing of organic reactions with particular emphasis on coupling reactions. We feel very good at this field. Some maybe called Hartwig coupling, Ullmann, Suzuki, Heck, Sonogashira, Kumada, and so on. And we can also offer our help or support in purification of compounds. Our in-house research is focused on the next generation of OLED emitters. We believe that third and fourth generation of OLEDs, TDF and hyperfluorescence, the future belongs to these generations because of cost and efficiency. Why to choose Noctiluca as a partner? We are passionists and we love challenges in the field of organic chemistry. So are ready and happy to be hired as dedicated R&D team. I ask who are our potential partners? OLED display manufacturers in case
I think we're having some technical issues with your sound, Piotr. Muy pillazo, jak się masz. It's so great to see you again, Piotr. Let me just quickly summarize here. It is very important to understand that there are many suppliers right now of polymer technology, but we have one in Europe. We have a company in Europe can provide any customized solution all the way from Wrocław, Poland, and they are looking forward to understand your challenges. Piotr, let's try to find the challenges. So allow me to come back to in my opinion, as an optics manufacturer, my opinion, the hottest topic today, which is glass or plastic. Michael, you have heard about the supply chain for polymer technology. We have seen that glass is the solution. Could you tell us a couple of points that Michael from Audi could take to re-answer the fact that he was very quickly saying plastic? Michael, tell us. Michael Borison first.
Oh, okay. Thank you. So for organic LEDs, for OLEDs, they're very sensitive to moisture. And so we do need to protect them from moisture. So for applications that are, I'd say, either lower cost or extremely long lifetime, glass is definitely the preferred substrate. But obviously plastic provides some special benefits, even finer, curvature, bending and unbending. And for some applications where extremely long lifetime isn't required, like cell phones or other limited use time applications, or where cost is not as sensitive, like it is in, let's say, automotive, then plastic is definitely a viable option and a place for.
Don't be politically correct, Michael Borison. We understand each other here, but you said very clearly, sensitive to moisture. Moisture is a problem, especially now we are in November and it's very, very wet everywhere. Michael Ham, when it comes to moisture, people are saying glass is better, but you said plastic. Audi has no problem with moisture.
We have no problem with moisture, but I think the discussion is glass. And if you look to let's look to a headlamp. A headlamp is made out of 100, 150, 200 pieces. And the most important thing of this headlamp job is to illuminate and to make signals. Next job, what we have seen also for the rear lamp, that we bring in digitalization. That means smaller elements. they are inside of a lamp. If we look to the outside, they have to be protected from the environmental stuff. That means moisture, ice, water, also the washing stations or high pressure cleaning or acid or any other things. So this means that you have to protect the interior. What is inside, as my Michael colleague said, what is inside, that is then important that you have perhaps moisture inside. And then it is important to safeguard the parts, whether you have a micro element or anything like this, that can survive the standard automotive qualifications. That mean 3,000 hours of operation. Yes. And being shaken and drained and all the stuff that you can see with that crazy let's say testing cycles where OLED works has survived it, because they are in production also in the Audis. So if we talk out of the car, in the outer side, I think there is some plastic coating, the lens is red, or there is some other coating to prevent the general system. But what is inside, I think that is then more the question how to make it best, whether it's molding technology, micro molding technology, or whether it's glass. That depends. I think the totally different world is if you go inside the car, where you can directly touch these elements, where you can work with these elements. That is different to the outside, where the messaging, the information, the digitalization, and also bringing light outside is more important.
Michael, one thing here that you opened the door. I have already discussed at many automotive discussions. They always tell me, do not talk about reliability with German car manufacturers. They always tell me that. But I'm gonna take the time.
You can go to GM, which has the same strict relations. You go to Stellantis. You go to Ford. Hey, I was before I was in Audi. I was let's say 12 or 13 years in the automotive supply chain. They are all the same. Don't worry.
Do you see any particular challenges when it comes to reliability of the front of the headlight of the headlamps, when it comes to the plastic outside, to the coating outside, or to the glass inside? Is there any challenge that we should reinforce supply chain for high reliability?
Well, I think what is something that, especially in the outer part, that is we have extreme situations of shock. We have we have some vibrations. You have a car which has 4 wheels and has a suspension, but this suspension can't take everything away. So the better is robust in terms of let's say vibrations and shock resistance, then it works. The job of the set makers then, like ARVR, Hella, then is to make it stable and to make it let's say inside of the devices so that it works. But it works. We can see it very good with the OLED works results, where we have, and this is what I wanted to say. As I said at the beginning, the digitalization means that you have to make, in any way, pixelization. That means you have to display words, text, graphs, anything that changes, where the customer may select something, or where the car may, let's say, give some information, especially if we look to the future application of autonomous driving.
Let me go to ARVR now, because you mentioned it 3 times, and I think it's important that we understand from what are the challenges. Your job, Edward, Michael said very clear, your job is to make things stable. So are there any challenges today in different components that the rest of the room can help you with, or different technologies when it comes to higher reliability on the next generation headlamps?
No, yeah, definitely. I think all what has been said are very valid. I think we need to take into account, environmental very stringent constraints in the qualifications. So any risk that might be coming from given material or a given process that would jeopardize the range, would of course be an impact for us. So it's very important that we can fulfill automotive grade, temperature.
Many of the companies, Edward, are investing heavily, and Michael also, investing heavily on being automotive qualified when it comes to production. Do you need your suppliers of glass or MicroLEDs or MiniLEDs to be automotive qualified?
Yeah. Absolutely.
The guys from SUS Micro-Optics are smiling, and so am I, because I want to lately highlight that we are helping as much as possible reinforcing supply chain. Stay tuned for the next speaker. We go to one company also for the first time at an Optica event. We're welcoming many new friends today. I would like to welcome Paul Schule. Thank you very much for being with us. The company Elux, the floor and the attention of everyone goes to you, Paul.
Hey, thank you. Today, I'll be talking about something rather different from automotive. What Elux works on is large area displays. So think televisions, think public information displays. Sorry, that didn't seem to work. Okay, that's better. So the problem, as was stated early in the meeting today, is to assemble, say, 25 million LEDs. And this is a video from long ago that shows our approach about as clearly as you can. It's a stochastic process of assembling the dark circles, which are LEDs, in the light circles, which are wells. And what you see coming up at the next arrow is that there's always one site that's the last site to be assembled.
Paul, I think I will interrupt for a moment because I don't see the presentation running. I think raise hands who see the presentation running.
He needs to go presentation mode so we can see his stuff as clear as he deserves. Paul,
so
presentation
yes,
you might be sharing the wrong screen with us.
Oh, am I? Oh, sorry.
Who knew Elux before today?
How about
Olga
this?
did. She found the company. Not yet. I think you are sharing the now. Yes. You go to display settings there and you switch the displays. We'll be good to go. You see on the top of your window display settings.
There we go. How about this?
No.
And now, yes, go there. You know what? I think you are sharing the wrong screen with us, but that's okay. Why don't we continue? When he fixed that, I would like to let everyone know that after this presentation, we're going to call to the stage our corporate member of gallium nitride on silicon manufacturing. So Alexander Lucin, be aware, you're going to be the next on stage. We really want to understand from you, as we have been discussing right now, that we need higher efficiency. And we want to see how gallium nitride on silicon will be the solution. Paul, button on the Zoom window, there's a green arrow up, you press it, and then, very important, you select the window that you want to share with us.
Yes, that's what I seem to be missing. How about this?
It's coming, it's here, and it's fantastic. Yes. Thank you so much.
Sorry. That's sorry for the glitch. Too many screens and
familiar problem.
Yes. So as I said, we are.
You stopped sharing.
What? Oh, I'm very sorry.
No problem. We can actually jump in, and Elise, our emission control, can share the slides. Elise, please go ahead. So Paul, you will just need to watch and comment.
Watch and talk. Okay.
Exactly. That's even.
I'm really sorry because the
like Steve Jobs, he was always speaking over his video presentations with someone while someone was controlling the video.
So let me get to the content so that you can understand what's going on here. Go to slide, the next slide, please. There would be, this would be a video that shows fluidic assembly. It's massive parallel, which is its advantage. It's cheap, which is its second advantage. But of course, it's random, so that is a disadvantage. Next slide is the overall view of how we do this. On the very left-hand top are the micro LEDs. They're a dish shape. The thing you should notice is that they're very closely spaced. We can go down to about 2-micron space. So we efficiently use the wafer. The second picture is selective harvest. One of our advantages is that we can remove defects from the ink. If you see the small view of the Falcon tube near the center, those are about 3 million LEDs in solvent. So they're really pretty easy to handle. You can see on the right-hand side our electrodes and our capture sites, and that builds up a pixel. So what we have is a way of using the current manufacturing technologies for lighting, for large area display panels in order to make micro-LED displays. The technology works for what we're doing down to about 350 PPI. For next generation, we can probably go to 800 PPI, but it's really not suitable for ARVR. On the next slide, you can see the advantage of the randomization from fluidic assembly. On the right-hand side, this is stamp transfer, I shouldn't say pick and place. And on the left-hand side is fluidic assembly. You can see the pattern mirror pretty clearly on the right-hand side. The backplanes are the same between left and right, and the LEDs came from the same batch. They're configured somewhat differently for assembly and for pick and place. Final slide shows the overall view of what we do. We use really simple tools. On the left-hand side is our R&D tool that cost about $13,000. The automated tool on the right is significantly more expensive. It's does 15-inch displays automatically, cassette to cassette. So we can do things pretty low cost, very high utilization of the LED wafer, which is important for cost. With selective harvest, we can remove defects from the ink so we don't assemble bad LEDs. The randomization, of course, is important. Pitch expansion is trivially straightforward, and it's a pretty gentle process, so we can use any kind of LED that you can get into ink. Because it's a simple process, scaling is in one dimension across the glass. So we can go up to Gen 6, which is the biggest fab that has LTPS. Thank you.
Thank you, Paul. Because you've mentioned about, that the process is very well adjusted for the developing displays or TVs, for instance, for the announcements. So what are the maximum dimensions, for instance, for the display that you can announce? I can imagine it's quite a huge pick and place machine.
Well, we can do anything for assembly as pretty much as big as you want. You could do Gen 10.5. The real problem is whether you have TFTs to drive it. Mm-hmm. And so one possibility, if you're going to really large displays, would be to use FR4 chip on board kind of thing where you're driving with silicon. So, I think we can compete all the way up to stadium-sized displays if with the right partners.
So who would be the right partners? This is, as always, the optical question. What can others do for you?
Sure, this is the critical question. For making large displays, there are 0 candidates in Europe. Mm-hmm. There are 0 candidates in the United States. Arguably, there are 0 candidates in Japan. In Korea, there are LG and Samsung. In Taiwan, AU and Innolux. In China, TCL, a couple of others. Those are the display companies that are candidates for large area micro LED, I would say.
Okay, I think we have. I was looking carefully at Alexander from IS Semiconductors, and with every manufacturer that you were mentioning in every country, he definitely was agreeing or disagreeing. Alexander, what are your comments? And then let us know.
Yeah, thank you. Thank you, Paul, for sharing. I think this self-assembly approach in one way or the other is really making a lot of sense to bring this into volume, and in particular the randomization, because the wavelength homogeneity on the wafers is a critical challenge. And actually, one of the advantages we bring with our technology, we have one bin on even 300 millimeter wafers. And but that is then solvable by this approach. And I think a few people believe that actually this is one of the big opportunities of micro-LEDs, that it can shake up the industry. Yeah, that we don't need to rely on, and I think on the big ones and the big capital investment. I'm really curious to see whether this pans out. But for example, in the US, there's Stratacache using this approach. Yeah, they are very ambitious on that. And in some other countries, there are some other people. So let's keep our fingers crossed for some more competition.
Well, that's a very good point, because the companies that I didn't mention are the large area display companies that have been using discrete devices. And as they want to move down into television, going from chip on board to something more like micro LED would make a lot of sense. And so I gave the most pessimistic case if you say, if you think you need the infrastructure of a conventional display. If the infrastructure from a big display can work, then yeah, that would be better.
Alexander?
Yeah, I'm sorry, I don't want to hijack the discussion here, but maybe a question to the automotive folks here in the session. How do you people think about micro LED advantages, in particular when it comes to free shaping of these displays, for example, in the dashboard region? And do you see that there's new companies coming up trying to solve this, tackle this, or you think it's going to be the incumbents, the names which Paul basically mentioned?
Hendrik, would you have a comment? Because I guess you're working with many tier one car manufacturers. What do you see is happening in the field?
We see how to say growing interest in OLED and micro display, larger displays as well as micro displays, but there's no clear winner yet. So neither in the question if what will be the next head-up display, for example, solution, if this will be a large semi-transparent display in the windscreen or a smaller projection-based engine using a micro display inside. So it's still a race.
Yeah, whoever will win it. Actually, Alexander, I know that you are the IO Semiconductors is specializing in the developing wafers specifically for the LEDs and then micro LEDs. So yours also is is an Optica member. We would very much like to hear about your solution and possible maybe collaborations with Paul. So please share your slides and let us know more about your technology.
Yes, thank you. I had the intention to cut the technology part really short, but in a nutshell, like you were suggesting, we do the wafer. So in the way you can think of this being the base material for all the displays, and we do this in such a way that you can put them on large wafers, which then allows you to go into silicon fabs for the processing to have highest possible yield and also lowest possible cost. And that really becomes important, like Jose was pointing out at the beginning. Yeah, when you have a 4K display, we're talking about 25 million individual devices being put into such a display. Yeah, all these micro LED chips, all of them need to work. So I wanted to give you here the point of view on what we can do, yeah, to the industry, if you want, and show you what we do today in working with customers and advancing their micro LED solutions. So for some, we do customized development work, which is really based on the experience we have accumulated over the years with different partners along the value chain, and then we bring them in for projects where a partner may not have these leads yet. Yeah, there's a couple of new entrants in the industry. We support this with sample wafers, so fairly small volumes, but we also have a partnership with a large LED company to really then also ramp this into volume production. And we had a discussion recently in another call today where this is actually the topic, yeah, when GaN on silicon will go into production and moving in volume, and this is actually happening now with this LED industry partner. And last but not least, in a way, we also then offer our technology as a IP licensing if people want to insource the manufacturing, which for some people is important. And we make sure that this works by also transferring the technology. So it's not only a license contract, but we actually implement the technology at the customer, so it works. Yeah, and there's a lot of technological advantages. One I mentioned earlier as a comment to Paul's presentation, which is the uniformity. So on these 203 millimeter wafers, we have one wavelength bin. So it's 2.5 nanometers across the whole wafer. And that really then allows you, if you, for example, build the micro displays where you bond the CMOS wafer with the LED wafer, that all of them have the same wavelengths. Yeah. So that, in a way, is what we can do for the industry, and looking at what the industry can do for us.
Exactly.
Yeah. You know, I'm German, and there's a saying that German entrepreneurs are never satisfied. So I was thinking about putting here more customers as the first item, but I felt that was a little bit too plain. So we see that a lot of people in this industry have the problem, and we actually also have this, that we work with some customers and they are so super secretive, we cannot share any data. And so we have met more and more people now who have an interest in also sharing data, which are also people along the value chain. And that's actually people we're looking for. So if you want to demonstrate something and you need micro LED chips for that or epi wafers, we are more than happy to engage, in particular when you then also have an interest in sharing these results with the industry in a more public way than is typically the case with all our secretive customers. Yeah.
Well, let's see. I mean, who would be, Niall, would you be interested? Is there a possibility that your materials can also be compatible with the micro LEDs?
Yeah, I was just thinking about that. You know, if
I saw you
yeah.
I saw you taking notes, so that's why I asked.
You see everything, yeah. So yeah, you know, I'd be interested if there's some way to collaborate and see if we could apply our material on top of your wafers and you know, affect the you know, the brightness and the efficiency of these LEDs. Yeah, I can follow up with you on that.
That sounds like
looking
a good
forward
idea.
to that.
We actually have another question to Paul, and it comes from one of our speakers from the X display with Nikhil. Nikhil, could you please then unmute yourself and ask your question?
Hey, thanks, Olga. Paul, many thanks for sharing the latest in the microfluidics domain. Really excited to see. I'm curious, maybe you touched upon this, but would love to hear your thoughts, just in general community perspective. Microfluidics is great in terms of speed, but what's the direction for kind of working towards if you want discrete independent emitters, colors to be precisely placed in specific positions on the backplane? How is the microfluidic community sort of evolving to address that?
Or three emitters, 3 color emitters. Yeah. There are really 2 approaches. What you need is some kind of selectivity between the different colors, and so you can use either different sizes or different shapes. There's a very recent paper by people associated with LG that uses dielectrophoresis and different oval-shaped wells. That's really quite innovative in order to get RGB emitters. Our approach is not that, because I argue against dielectrophoresis. It's too complicated, and then you have to do the wiring from the top. So I think the way it's going to be is it will be 3 sizes. And so you'll do your highest efficiency last, your lowest efficiency first. And so I think you will assemble reds, then greens, then blues, okay, by size or by shape. You can also do it with squares and triangles, and we've done that too.
Speaking about efficiency, we actually have a question coming all the way from beautiful Neuchâtel. Wilfred, please unmute yourself and ask.
Yes, I'm still wondering. I attended a couple years ago an event at IMEC where they were talking about micro-LEDs. So there were different technologies presented, and also the efficiency was always a topic, because micro-LEDs are so small. You have effects by the sidewalls. We could see that nicely actually on your SEM pictures, on your micrographs. Paul, so what is the typical wall plug efficiency these days? That's one question I have. And if they are not that efficient, do the substrates heat up a bit, or how is this handled these days?
That's an hour's worth of questions. Our current efficiency is around 30%. Ours is not the best. These are for blues. Non-radiative recombination problems with reds, gallium arsenide-based reds is really severe. A few percent, 5, 6, 7, 8% is what I'm seeing. And so, yes, temperature is an issue, and how you get the heat off the backplane is definitely a big deal. That's a long discussion.
Very much for being very open about this, because this is the other elephant in the room besides the costs, of course. I mean,
well, some people are doing better. I think the best micro LEDs that I know of now, they're, again, to the proprietary question, lots of people are doing work on ARVR, and I'm not plugged into that. So I have to assume that they're doing better for efficiency, or they will have serious problems with how to get the heat off people's heads. I think play nitride is producing moderate-sized LEDs at around high 30% efficiencies. They're not available to us.
Okay.
I'll just build on to what Paul said. I think, Paul, your numbers are spot on, and echoing what you learned. I think what we heard from our partners too, and where we measure the numbers, the blue and greens are certainly in the 30s or even higher. I'm talking about these double-digit micro LED, double-digit micron sizes.
Yes.
Red's generally been the one that's limiting in the micro LED world, which is the opposite in the OLED world. Right. And a few years ago, red was a big deal, and great strides have been made by the community. And I think the numbers that we hear are going beyond teens now. We're entering in 20s, at least in the R&D setting. So I think I speak with a lot of optimism that I think there's a lot of headroom for reds too. So 30 for all colors is in the horizon.
Well, then I think it was such an extended comment that I believe you just need to basically to move slowly from commenting to actually presenting. Nikhil, sir, you're on. We're all looking forward to learning about what the X display does.
Excellent. Let me orient myself and make sure you all hear me and see me.
Well, we see the screen, not you, but we hear you.
Great. You are seeing my presenter screen, right?
Yes.
All right. Hey, many thanks again to the Optica team for inviting XDC. It's a pleasure to be here, being part with this esteemed folks representing the display community. My name is Nikhil Jain. I oversee the LED development effort here at X Display and work with our supply chain partners. I also lead some of our programs with new customers as they scope new and exciting display applications. Some are really new and upcoming display opportunities that we haven't imagined yet. And so stay tuned, a lot of exciting stuff coming in years ahead. With that, I think the things I wanted to cover today is give you all a feel for sort of how we build from components all the way to MicroLED displays. What you're looking on your screen are some of the solutions and the offering in terms of the components that we do. On the left are the emitters. Wait, are you guys seeing the right screen? Yeah, I believe so. You are seeing the emitter screen, right?
Yeah.
All right, okay. So yeah, these emitters and silicon-based drivers are the fundamental building blocks. They are micro devices and can both be transfer printed onto many different backplanes and open up applications for consumer displays, video walls, automotive applications, etc. Looking on the left, these are different configurations of LEDs that we work with, and we are headed towards miniaturization. On your left is a classic pads up LED, where we would do a redistribution layer of metal to interconnect from the front, and the emission is in the opposite direction. Our flagship LED form factor today is flip chip, where we do interconnections during transfer printing itself. Here, the emission is away from the backplane substrate, generally speaking. And I think where we are headed is obviously towards cost and miniaturization are these vertical LEDs. These are some of the devices we make in-house, and we're routinely looking for partners who can take on and help scale this. This is one of our challenges in our ecosystem, sourcing LEDs sub 10 by 10 microns, which are high performing and good yield, and more importantly, just supply for them is a challenge for us. Hence, we've taken on this effort to develop these internally for prototyping efforts. On the silicon driver side, we make these driver chips that are the brain for the display circuit. These have some inbuilt memory onto them, and they kind of take in place and do a lot more than a TFT offers. These are 8-inch silicon substrates that we have, and these micro ICs are about 50 by 90 microns in size. Image here shows 2 pixels side by side. These are redundant pixels, 2 ICs and a set of RGB each. And so thinking about cost, looking at the bottom right, this is one of our latest new offerings we refer to as cluster micro IC. Instead of 1 IC per pixel, this IC is geared towards driving 16 pixels, an array of 4 by 4. So that's where we think the cost aspect of silicon drivers can really be targeted and work towards mainstream. So these are our core components. And I want to place a plug for micro ICs. So these micro ICs, I mean, you all know the display industry is on the tune of more than 160 billion, and OLED has a lot to offer. And we believe in this theme geared towards, we want to enable these displays of today to become better while we work towards making the ultimate future MicroLED displays. So in that sense, these micro IC wafers, and here's a demonstration we made almost more than a decade ago at this point, where these are OLED emitters driven by micro ICs. And you don't have to take our word for it. Here's a report from the OLED Works Summit, and the author there kind of goes on to attribute that with micro IC drive architecture, even in the OLED world, you could have power savings on the order of 50%. And essentially that comes from the ability of these micro ICs, because they are single silicon crystal based, they're higher mobilities, lower leakage, so you can more optically drive the emitters and even their power savings in terms of the data management. So yeah, we are selling these micro IC wafers to the micro LED community and as well as to the OLED community. That's the desire. So having touched on the building blocks, which are core, I want to next talk about the heart of our technology, which is micro transfer printing. This is the core jewel This kind of originated in early 2000 at Professor John Rogers' lab. It's a very simple system in that there's motion, optics, and stamp. And it allows pitch expansion from the source wafer, which could be an LED wafer or an IC wafer. And you can place these components onto a display, which could be sizes even beyond Gen 4.5, which is about a meter-size display. So let's look at transfer printing in action. I'll show a video here. A stamp comes in here. The stamp is designed to pick every fourth IC. You can see that. ICs are picked, millions of devices are picked and transferred onto wherever you want to put on glass, plastic. We had that discussion earlier. And this can all happen on the order of 10 seconds. In this case, the IC picked is about 50 by 90 micron. But a similar fashion is employed for transferring LEDs as well. Our global footprint, we've installed over 30 tools to this point, a lot in US and Europe, and expanding in Asia too. Bottom of your screen, you're seeing the evolution of different transfer printers we've built over the years. Over a decade plus into making these, we kind of commercialize this at Semprius for micro solar cells, but all the energy towards today is on micro LED displays. So our latest and the greatest is this panel display printer that we've built. It could take up to 12-inch in terms of the LED and IC wafers, and then can print onto displays that are Gen 4.5. This is not the limit. This is where we are. As the needs from the customers grow, we have plans to go beyond that too. But this can cater about a meter to 3/4 of a meter in X and Y dimension of displays. For transfer printing, we can do a lot more than emitters and ICs. Here is a whole slew of different applications. On your screen, you're looking VCSELs, photodetectors, solar cells, lasers, transistors, miniature devices that can be picked and placed and allow these heterogeneous integration, which is again a big topic in the community. Coming back to displays, in terms of our precision, we kind of transfer these devices with precisions 3 sigma less than a 1/4 micron or better. And I talked about throughput. We are at about over 200 million units that can be transferred in an hour. You heard speakers talk about 25 million pixels emitters in a 4K. So we're talking about more than 10 displays, double-digit displays that could be assembled in an hour, which is not possible with traditional pick and place. And we see there's a clear roadmap in our technology to hit over 1 billion units that can be transferred per hour. Talked about the components, I've talked about our core transfer printing technology. They come together and enable a family of devices, these integrated packages, what we refer to as pixel engine technology. These are the smarts where you have the emission and control the driver IC together or separate. And so this pixel engine micro IC is the driver only chip. I talked about the smaller size, which drives each pixel, and then a bigger cluster, this drives multiple pixels together. So with these, you could be building micro LED displays or OLED displays. These are the drivers. In the middle is a package we refer to as Pixel Engine RGB. This is an emitter-only package. This is an RGB package that you could essentially take it and enable TFTs based displays too. And then on the right, we combine all of it together. Here's micro LEDs printed onto a micro IC. This is a micro LED plus micro IC package. And I think we are strong believers of technology, and in a component like this, the end display maker really has to do transfer printing only a few times to enable the display. This is where some of the earlier conversation is reflected. This saves huge OpEx and CapEx for the end display maker. And the foremost is a version of that, but an SMT flavor. This is geared to video wall market. These are the big displays you will see at airports and sports events. Those big displays benefit with the component that, again, is geared towards micro IC plus micro LED combo. And with all these components, we build some of our best displays and some of the best displays the community has seen. Here's the architecture for some of the displays you're seeing on your screen now. Allows us to build displays on the size, here for demonstration purposes, about the size of a typical iPhone. These are high transparency displays. The image on the right, the dog, this is actually displayed on the display, and this one on the left is an actual transparency of the display shown with a dog behind it, which is not displayed by the display. Talking about brightness, here's a demonstrator of our display on the top right and an example of a phone, both showing the same content on a sunny day outside. You can read on the top right, but you can barely read on this phone. It kind of shows on to you the power of micro LED brightness. Here's a combination of bringing micro IC and RGB together and some of the displays that are enabled. This is really powerful for consumer display applications. We had discussions about need for flexible displays. So flexibility and transparency together can offer a lot to automotive displays. And finally, we're not limited to just emitters and ICs. We could embed sensors in the display and add more smarts. And here you're looking at these infrared emitters put in for other novel AR/VR applications too. With that, I'd like to put a thank you note to a lot of our investors and partners. We work with LED partners, silicon companies, major video wall makers. So they enable a lot of what we do. So thanks for that. And with this, I'll come to conclusion. So many thanks for listening. This is our wonderful team. We're based here in North Carolina with a lot of our global teams across US and Europe.
A lot of happy faces and a beautiful sunshine. So I guess it was taking around this time when we are enjoying such a beautiful weather everywhere. I can tell you one thing, your colleagues from XFAB say hello. They are really excited about this success story, Nikhil. But I would like to ask you the Optica question. Here is the entire supply chain. We manufacture micro LEDs. We have the material, the gallium nitride silicon from Alos. We have the micro optics of SUS. What can we do for you? What can you do for us?
Great, yeah. So in terms of what we have to offer, so we offer mass transfer printers and we are selling micro IC wafers. So anyone in the community who are gearing towards using these micro ICs and don't have access to TFT lines or want to gear towards low power applications, we are selling micro IC wafers into our ecosystem. And also this Pixel Engine family is coming together too. So that's a plug for selling micro IC wafers to the community. Your second part is what are we looking for? That's a good one. We have this desire to add more sensors in our system to open new functionality. So looking for ways to collaborate and offer prototyping services to others too, where we can embed sensors into the displays and enable functions together with our suite of technology such as touch and infrared detection, etc. Yeah, so that's just the good stuff.
What is the standard for your customers? I know you are serving many of the micro-LED display manufacturers worldwide. What is the standard precision? And please tell me in nanometers or micrometers that is needed for the pick and placing of micro-LEDs.
Let me make sure I heard your question right. Your question is, what's our standard precision in transfer printing?
Yes.
Great. Yeah, so I touched upon some of the numbers. A best example to illustrate that is you see these Pixel Engine devices that we've built. It has a red and a green and a blue emitter. The red, green, blue come from 3 independent LED wafers. And they're placed on a package where they're about just a couple micrometers apart. So we do that repeatedly at millions of units for a lot of our prototyping and customer programs. So our transfer printer, when we qualify, we quote numbers on the order of sub 1 micron precision, the 3 sigma, both in X and Y, but we routinely hit numbers even down to quarter microns.
Thank you very much for being with us today. We're going to come back to you. We have a couple of minutes left, and we wanted to use this couple of minutes to highlight two companies that have been running towards making a success story of quantum dots for displays. And we're going to go first to Poland and then to Belgium. I'm going to tell you why. Because we have two great companies, Q&A and Cassian Dot, that are here looking for partners, looking for partners that can actually take quantum dots to the next stage. A couple of weeks ago, we got the Nobel Prize. Say we, because the whole quantum dot community, we feel that we are a little bit part of this success. Let's start with this quantum dot session. First, let's go to Brosua. Q&A technology. Arthur, Chesh, secure part for being here with us. Tell us what Q&A is, and also tell us how we can help you be even more fantastic than you already are.
Thank you, Jose, for this nice introduction. So, hello, everyone. My name is Arthur. I hope you see my screen. I'm CEO and founder of Q&A Technology, company located in Poland. So now we are 25 people on board. And all of these guys are focused on one goal, to develop blue light emitting heavy metals free quantum dots. This is our specialty. So we can offer quantum dots with emission from 450 to 460. But also we have materials which emit a little bit lower wavelengths. We can deliver these materials in different solvents. And I think this is also a quite unique in our company. We can deliver materials in polar, non-polar solvents, in monomers, in the powder form as well. We also work on inks formulation, and right now we have UV curable inks based on our blue quantum dots. We also have quite extent know-how on other types of inks. So if you guys have quantum dots and have some problems with making inks or other types of formulation based on quantum dots, we also can help. And we develop our materials toward two kinds of application. The first one are micro-LED displays, but the special ones which are using the UV backlight. So you use the UV LEDs, and then you need, of course, except of red and green, you need also the blue quantum dots to get RGB. But also we develop our materials toward the electroluminescence display technology, where you use the current to excite the quantum dots. And here you can see a first prototype of LED device using our quantum dots, and this is the electroluminescence signal. Just to add a few words to what we do, we also simultaneously focus on scaling of our production. So in the company, we not only develop materials working on the surface engineering and on ink formulation, but also we develop infrastructure. So we designing and developing our system just to allow our clients for smooth transition from this R&D test to the pilot production, because we know that this is a very big issue for startups that to go to the next stage when you ask for larger quantities. So we try to fill that gap from the very beginning. So that's it from my side for the short intro. So what we are looking, we are looking for partners. It's a quite demanding technology, and it's not only the clients are needed for us, but the partners, the people who'd like to involve in cooperation with us. And I think what we can offer is that we can give you to hand a quite unique material, which allows you to test a new approach with the UV backlight to test how it works for micro-LED. And also we work a very brave companies in Europe who would like to go into the new technology of displays based on electroluminescence effect. So that's all from my side.
Thank you very much, Arthur, for being with us. And we're going to have the round Q&A together. But first, allow me to bring to the floor to our second quantum dot manufacturer counterpart, coming all the way from beautiful Belgium, Igor Nanorgesny. Thank you very much for being with us. Tell us what's custom dot.
Hi, it's a pleasure to be here in such a nice community. I'm Ihar. I'm a CTO and co-founder of Custom Dot. We are a spin-off of University of Ghent in Belgium. Quite complementary to Q&A actually that just presented. Because we focus on actually red and green quantum dots rather than blue. So together we can have all the colors you need for display actually. Our mission is to help micro-LED companies to actually get the most out of quantum dot color conversion technology. How we do that is we focus on key expertise of ours, which is quantum dot synthesis. So we synthesize our own quantum dots. We have a great team who can do that. Quantum dots, they're nanomaterials. Very important is to adjust the surface of this nanomaterials to retain their optical properties, but then also to integrate them in an ink. So the next step of ours is to formulate a quantum dot ink tailored to industrial printing methods. and then we assist our customers in developing actually a process flow, so a patterning process flow for them to help them integrate it into their processes, and then also help with the device engineering to actually get the most out of quantum dot color conversion. I hope with that I do answer the Optica question actually. In the end, our product is a quantum dot ink that is specifically fit for a special process flow of the customer that they can buy in larger quantities and plug in their production process. Thanks.
The floor is open for questions for everyone. Ask whatever you want to know about this upcoming technology. Let me kick off. Igor, Arthur, what is the current technology readiness level for light-emitting inks?
Yeah, so since I am already unmuted at start, if that's fine. Quantum dots, they're already there for LCD and from the beginning of this year for QD OLED application. They're not there yet for a micro-LED application though, because the key selling point of micro-LED is high brightness, of course, where traditionally quantum dots actually degrade under such a high optical flux. And we're talking here about tens of thousands of nits, right? Or ideally even more than that. So for micro-LED applications, TRL is rather low. We believe at Custom Dot we have a unique technology that can actually achieve this high optical flux. Our quantum dots are known to be photostable. There's still a path needed towards industrialization of that. So if you would put a number, something like TRL6 is there. We believe that in a close partnership with a partner, we can quickly accelerate that, get from TRL6 to somewhere like TRL8, and then actually work together with the established chemical companies who would actually pick it up and bring it to the next level and then supply our customers with larger volumes of ink.
TRL6 is a very high TRL, but all right. Arthur, what's your take on this?
I think it's hard to add anything more to Igor, but I think the most important is that it's quite complicated technology. If the people ask about the stability, we always ask at which conditions, because depending on concentration, depending on monomer, depending on many parameters, we can play with the ligands with quantum dots in a different way to fill this the final parameters of the device. But as Alexander mentioned, if the people not sharing their results, it's very hard for us as a material company to help these guys to reach the goal. So I think it could go faster, but it needs a much more open cooperation between the companies on different, supply chain stages, because we can really do a lot of customization, but we have to really understand the substrate the client is using, the printing head he's using, the expectation regarding the thickness of the layer he's having in mind. So there's a lot of really small things which make the whole story, true.
Michael, I know you, Michael Ham from DVN and from Audi. I know you're scouting these new technologies constantly. You got here two of the leading companies, at least from Europe, two of the leading companies that can bring quantum dots to light-emitting applications. What comes to your mind? How would you challenge them?
I think my first thoughts with this OLEDs, looking to this and what we had before for making, let's say, large-scale micro LEDs, I think it is a super idea to have these quantum dots that then are deciding the color, and below then you have more the standardization part, where at the end this brings the chance to have RGB colors in a display, where the display production is not, let's say, assembling RGB LEDs, but this gives us let's say, perhaps the chance to have that breakthrough to bring it to an application with a higher serial number. We always know that the generation 0 is the hardest to make because nobody takes the risk and nobody wants to pay the money. But this perhaps opens the door a little bit to start in any generation 0 and then to make the big step in mass production.
Michael, you see that they are telling you that they have very high TRLs on TVs that are consumer products. So the first reaction for me is like, if you have very high TRL in consumer, then other markets should be easy, right? What's missing? What is the ingredient you think is missing for these guys not to do more business, for example, in automotive? Is automotive qualification a challenge?
No, it's perhaps you have to find the application that is interesting for the end customer who has to buy it. You know, today we are talking about a car. If you look to a Tesla, which is a smartphone on 4 wheels, so we have to find the super application that where you can't avoid the products that Arthur and Igor and all the colleagues were showing. That is the big thing. Find the product number 0.
Paul Schuler, you come from a company that has links to Foxconn, to Sharp. You know what it is to make things in a volume production in very low cost. And then these guys from Poland and Belgium come to you with the beautiful quantum dots, which are fascinating. Quantum dots are fascinating. What things come to your mind? What advice would you give them for them to help you with your preferred future?
Well, I personally believe that the RGB with quantum dots is the right way to go. I think
yes,
the reds, well, the reds are really hard, and they're hard in a lot of ways for the LEDs. So I firmly believe in the quantum dots, but the cadmium is out. Japan will not accept cadmium, so that takes you to maybe the inorganic perovskites. The technology matters, and that's not my specialty. Obviously, I am a consumer of quantum dots for color converters, but I think that's the way the large area displays will be done, is with color conversion.
I fully agree with you, and I can tell you one thing. We need to address the challenge of perovskite supply chain today, and this will be done that we'll do in one of our upcoming meetings next year. I think this is one of the ones to watch. The cadmium challenge on Japan is something that we also need to address very quickly. First of all, I would like to tell you that we start on time, we finish on time. This is how we run at the meetings, but this meeting was spectacular. It was our first meeting on displays, and we managed to bring the automotive industry. We managed to bring the consumer industry. We met Paul Schuler, in my opinion. All of you were great, but Paul was the winner of today's edition of the Quantum Online Industry Meeting. Let me tell you one thing. Many people are asking, how can we help you do your job? And they say, can we give you money? No, we don't want money. Can we give you energy, smiles? We love them. But what we really need, the Optica industry, the companies worldwide, what we really need is for you to become Optica corporate member. This is the only way you can support us. You get access to market reports, you get access to events, you get invitations, but the most important thing you get is our time. The Optica industry team dedicates our time to the industry. We are running now a 25% discount for new members. 25% discount, which means that is not a lot of money. Please join Optica. Join us. Thank you for making our dreams. Thank you. All right, the meeting is over. Let me ask IT, you were great. A smoothless meeting again. So please switch off the